Hi, welcome to the work of Friends of Casco Bay here on the coast of Maine. I'm Staff Scientist Mike Doan, and today I want to talk with you about one of the things that influences change in our continuous monitoring station data. We collect data through our continuous monitoring stations, which are affectionately known as cages of science. And we collect this data to understand long-term change in Casco Bay as a result of climate change. But along the way, we look at short-term changes in our data. And we look at what's causing those short-term changes, what's responsible for the variability we see seasonally, or monthly, or even weekly. So today, I want to talk with you about phytoplankton, those single-celled microscopic plants in Casco Bay that make up the base of the food web. They are vitally important, but they do cause change in a lot of the other measurements we collect. We look at the amount of phytoplankton in the water by looking at chlorophyll. Chlorophyll is the green pigment found in all plants, and the more chlorophyll you have in the bay, the more phytoplankton you have in the bay. And that brings me to our first graph here. We're looking at a graph of the daily means of our data. This happens to be looking at chlorophyll. We're looking at months across the bottom here, so you're looking at the data, the chlorophyll data in this case, over time. And what I want you to notice is this big spike in early July in the chlorophyll data. This is telling us that there's a whole bunch of phytoplankton in the water, a large bloom of phytoplankton. Now this bloom of phytoplankton will influence or change other parameters that we measure. Phytoplankton, like all plants, go through photosynthesis. That process takes carbon dioxide from the water and adds oxygen to the water. While we're looking at this bloom of phytoplankton, seen here in the chlorophyll data we collect, we're going to see a few other things take place. First, this is a graph of carbon dioxide now, the partial pressure of carbon dioxide, but it tells us about the amount of carbon dioxide in the water. And you can see that in early July, sure enough, the amount of carbon dioxide in the water drops, gets lower, because that bloom of phytoplankton is taking it up through the process of photosynthesis. If it's taking carbon dioxide out of the water, this bloom should also be adding oxygen to the water. And in fact, that's what we see. Early July, we see this big spike here in the amount of oxygen dissolved in the water. That bloom of phytoplankton, again through photosynthesis, is adding oxygen to the water. And we can see that here in the data. The last thing I want to share with you is pH, the acidity of the water. And as the phytoplankton, through photosynthesis, remove carbon dioxide from the water, they are actually increasing the pH, meaning lowering the acidity. That's counterintuitive, but the higher the pH, the lower the acidity. And by removing carbon dioxide, you're supposed to see less acidic conditions, and we see just that here in our data. So it's wonderful when the data all sorts of agrees with what should be going on. But this is just one example of how one event can influence other parameters that we measure over a short time period. If we step back now and look at longer time periods like a season or a year or many years, we can begin to tease out what is influencing the changes we see. So as we continue to collect data, we'll continue to learn about what the changes are and what's driving those changes. And I invite you to watch along with us to continue to track this data. Go to our website, cascobay.org, and look at the data we add. We'll be adding graphs just like this. We'll be adding graphs that compare site to site, year to year, and we can really start to see how the bay is changing, even on a short-term period like this, and perhaps try to find out what's causing those changes.